Okay, let's start now. So, very first day I told you maths is a language. It's a language. Okay. Then digits we call alphabet. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are digits, no? So that is alphabet. So today I am going to tell maths is a world. That is a world. Okay. Maths is a world. So in that world we have many different machines. So in real world also we have different machines, no? We have different machines, car, sometimes any other machine, train, or likewise we have many different machines. So they do some operations, no? They do some operations. Then that machine has specific tasks to do, but some machine has multitasking machines, no? Some machines are multitasking, some machines are specific tasks related. So in mathematics, it is a world. In that world, there are machines. We call their functions. So in that world, that contain function, that is about some functionality. No? Okay, now you see, just you think, here a machine. So we have inputs. So we have outputs. So these outputs are corresponds with inputs, no? Those outputs are corresponds with inputs. Then all inputs, they do some operation and that finally give output. So all inputs, they connect and they process and that give output. Then this is we call a function. So you consider we have some inputs. Let's say inputs. In mathematics, we put some numbers here. Sometimes that can be real numbers, that can be imaginary numbers, that can be complex numbers. Likewise, there are different type inputs. So here we have input pool. We call it is a set. Input pool is a set. Especially we define this one by domain. So each function has their corresponding domain, no? Each function has their corresponding domain. Later we will discuss what is domain and how to identify domain, what is implied domain and so on. Okay, but anyway you identify input set we call domain. Okay, then with this functionality that give output, no? Then this is we call range. We call that is range. So anyway, here this process we call function. In mathematics, we denote this one by functional notations and some properties of the functions. Okay, here domain, it has some elements, no? Then that element set, we usually say capital X, and here this range, there are some outputs. Then those elements we define, we say that set we call Y, set Y. Here domain X, so in this domain, we have variables, we call simple X. So that variable inside capital X, here simple Y variable, that inside capital Y. This is general idea of a function. But anyway, you identify function mean a process that has specific tasks. So it has input, it has outputs. Okay. Then we're going to analyze about functions. That is a function. Okay. Now here X we call independent variable. So Y we call dependent variable. Because Y connect with X, no? When I give input, then only that give output, no? When I give input, then only that will give output. Then here, this connection we define by a function. So it has specific rule. That function has specific rule. So you should usually think about expression like y equal x plus 1. Here now onwards you identify this is a function. So here input values, we can put values for x and we can get results from y, no? So here input values, here output values, result values. Then here input value, here output value. Then y equal x squared you identify this is a function. Then y equal sin x, you identify this is a function. Likewise, we have inputs and further we have outputs. Those outputs are corresponds with inputs, no? Those outputs are correspond with inputs. Okay, now anyway, here all these are we call functions. Further we have functions. Here all are functions. Functions. Okay, now here function, let's say f. Function, let's say f. So here fx, that represent f of x. We say f of x. So that result will be y value, no? Then y equal fx. This is one of our notation. Okay, f of x. You don't think this is f times x. This is not f times x, okay? This notation represent y is a function of x. Y is a function of x. Here y is a function of x. So fx we say f of x, or function of x, f of x or function of x. So those are general idea. Now you identify, we have variable inside here and we have variable outside here. Then here input variable, here output variable. No? Then this is called independent variable and this is called dependent variable. Dependent variable. Okay, and you think about some function like you consider a cylinder. This is a cylinder. So here, let's say here radius, let's say here height. Then we know this volume, we denote by pi r squared h, no? This is also a function. But the thing is, here r, h, both are variables. Both are variables. Radius, as radius varies, volume varies. As height varies, volume varies. Then here this function has two variables. We call multivariable function. Here y equal fx, then here we can denote this one v r comma h. Here multivariable, special two variable function. Then volume depends with radius and height. Volume depends with radius and height. No? Likewise, in nature also we have different connection between two variables. Okay, boiling point decrease with the height, with the altitude, no? Boiling point decrease. Likewise, there are many different connections. Then to analyze real world, we need functions. To analyze real world also, we need functions. So now we are in artificial world, digital world, and mathematical world. We are in there. Then all those worlds basically runs with multi-billion functions. Multi-billion functions. Okay, when we discuss about our world, so all the things has made by multi-billion functions, multi-million function, multi-billion function, many functions. Still they are found in functions. To describe all this real world, we need to identify different functions, different functionalities. Okay. Likewise, here we call two variable functions, two variables. Okay, two variable functions. Here single variable function. This one single variable function. Single variable function. Then the main thing you identify, function mean a process that has connection between input and output, that has specific connection. Then one function can do one single thing. Then each and every input has their result, no? Each and every input has their result. Okay? Then here this function accept only inputs that related with that function, no? Then the corresponding result will be specific one, unique one. Okay? Then every input has one output. That's the thing. So that is function. Okay, anyway, you put this sketch first. Okay, I think time's enough. So that is general idea, okay? But we need to discuss rigorous idea about this type of functions. Okay? Let's move further. Let's move further. Now you just say, so under functions, so I'm going to discuss especially main idea. Main idea and notations. Main idea and notations. I'm going to discuss this thing. Then especially I'm going to discuss about function types. Types of functions. So further I'm going to discuss especially domain, range, codomain, domain, range, codomain. Okay. Further I'm going to discuss about inverse functions. Further I'm going to discuss function of a function. We call composition, function composition. Functions composition. Then we're going to discuss even functions, odd functions. And further I'm going to discuss classifications. Of functions and their properties. And further I'm going to discuss piecewise function. Okay, and I'll add here main idea, notations and relations. Main idea, notations and relations. And relations. Piecewise functions. Then I'm going to discuss combined functions. Combined functions. These are the things that I'm going to discuss. So we have function. Function means interconnection between two variables. So it has specific rule, no? It has specific task. So if you think about inverse function, so we have one process like this. If I can reverse that one, that is we call inverse function. If I can reverse, okay? But each and every function we can't reverse. But there are some functions we can reverse it. And further, here piecewise functions. Further, I'll add here. We have some special relations. I'll add here relations one-to-one, and onto. We have two relations, 1 and 2. So these are the things I'm going to discuss under these functions. Okay, anyway, you put this sketch again. No need to worry about the things, but just to write. Huh? Here this one inverse functions. Inverse functions. So others are okay. No? Here even odd functions, classifications and so on. Complete. Okay, I think time's enough. I think time is enough. So now, especially in your A levels, we mainly focus about functions. In pure mathematics, we only deal with functions. Mainly we deal with functions. So we have many different functions like polynomial functions, quadratic functions, linear functions, modulus functions, trigonometric functions, and so on. So those functions one by one we have to analyze. Each of those functions, they have different properties. They do different tasks. No? So one by one we need to analyze about functions. One by one we need to analyze about function. But today and next day, I'm mainly focused about general properties, major properties of all the functions. All the functions, that's the thing. Okay, now let's move further. Now we know general idea of function. Now further you see, sometimes we see some relations, or some expressions. So you have seen y equal x plus 1, no? You have seen y equal x plus 1. You have seen x plus 1 equals 0, no? So all these are expressions, no? So you have seen y equal x, not y, just x plus 1. So here we have equal signs, but here we don't have, no? We don't have. And here we don't have y, but y is like 0, no? Y like 0. But here y x connection there, you say, if we have two variable interconnection, usually we say function. This is a function. It is a function. So algebraically now you can identify function type. And further we have some definitions, further we have things, okay? But for now you just identify two variable connection with equal sign. So here x plus y equal 1, here we say equation. We say this is an equation. So now y is 0. So when y is 0, we create equation. Here by equation we think about x-intercepts. So here x plus 1, we say a factor. Usually we define a factor. Here an equation, a function, likewise we can identify. So function has interconnection between x and y, no? So if had interconnection between x and y, therefore we can sketch it, no? So function, here we can sketch. Those sketchings are called graphs. We call they are graphs. Okay? So x varies, y varies, x variable, y variable, x independent variable, y dependent variable. Then by substituting some value for x, we can get y values, then we can plot it, no? So likewise, when I sketch these type graphs, sometimes some graph like lines, some graph like circles, some graph like parabolic shape, some graph like elliptical shape. Likewise, there are many different shapes. Okay, but you just identify here just like a function. Usually we can denote further here fx. Here we say function of x plus 1. Instead of y, now onwards you can put fx. Okay, instead of y, now onwards you can put fx. So this is new notation for you, but don't mislead. Here not f times x, that represent f of x. Okay. Now here another thing. Okay, you put this on SL. Here one another thing. Here discuss about x-intercept. Just write them. Huh? Here these are different shapes. But there are further advanced different shapes, okay? We have three-dimensional, we can advance. There are some advanced shapes as well. Likewise, we have different advanced shapes. Here these are generally, these are not that much advanced, but these are advanced shapes. But we analyze them using graphs. Okay, just put that idea again. Okay, you get that picture first. Okay, now you write this process, write this note. In mathematics, in mathematics, in mathematics, a function is a machine. A function is a machine that do specific task, that do specific task, that do specific task, that has inputs, that has input, and there are corresponding outputs. There are corresponding outputs. Especially each and every input has corresponding result. Each and every, underline it. Each and every input has corresponding output. Underline each and every. Each and every input has corresponding outputs. Go to next slide. Further you write down. A function is a relation. A function is a relation between two variables. Between two variables. Between two variables. One variable is called independent variable. One variable is called independent variable. Within bracket usually x. Within bracket usually x. The other variable is called dependent variable. The other variable is called dependent variable. Within bracket usually y. usual y. Okay, go to next line and write. There are multivariable functions as well. 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 Okay. Now further you write down some examples. Let's write y equal x, y equal 2x plus 1, y equal x square minus 3x plus 4, y equal x cube. First you see, x cube plus 2, x minus 1, y equal x to the power 4 plus 3x minus 1. Okay. So here one group. So it's look like x to the power n type terms addition, no? X to the power n type terms addition. Here x to the power n type terms addition. So here n positive integer with 0. Positive integer with 0. We say that type polynomial. We introduce that one polynomial. So further we can classify linear, quadratic, cubic, biquadratic, so on we can classify. But altogether we say polynomial. So here y equal 1. We call constant function. So we have constant function as well. So now further next group, y equal x over x minus 1, y equal 1 over 2x plus 3, y equal x over x square plus 1, 3x. You have seen them, no? So here another group. So when you consider upstairs, we have polynomials, no? When we consider downstairs, further we have polynomials. But anyway, we have division. Then division type we call rational. Okay, this is polynomial and this is rational functions. So we say this is polynomial functions. Here rational functions. Rational function means polynomial division. Polynomial division. Okay, now you see y equal root x. So while we are doing numbers, we discuss about square root 2, square root 3, so on. We call they are irrational numbers. Then here this is irrational function, no? Then y equal x minus 1 root. This is another group. You say that is irrational function. Irrational function. Here rational functions. Here polynomial functions. Now you can identify few of them, no? Now further you go. Y equal 2 to the power x, y equal e to the power x, y equal x to the power x. So exponent has variables, no? Exponent has variables, but here exponent constant, no? So exponent has variable, we call exponential functions. We call exponential functions. So y equal log 2 base x minus 1, y equal log e base 5x plus 2, y equal log x. So here we have logarithms, no? Especially we say logarithmic functions. logarithmic functions. Logarithmic functions. Further you go, y equals sin x, y equals sin 2x plus cos x minus 1. That contain trigonometry, no? We say trigonometric functions. Trigonometric functions. Okay. Further, there can be some relation like here we call modulus sign, no? Then parallel lines we say modulus. Y equal 2x minus 1 modulus. Y equal modulus x plus x minus 1 modulus so on. Here especially see we say modulus functions. Modulus functions. Modulus functions. And further there can be x plus 1 for x greater than 1 minus x for x less than or equal 1. Likewise there can be some composite functions. So especially we say they are piecewise functions. That means here we have only one thing, no, one relation. But here it says that for x greater than 1 we have one type, for x less than 1 we have another type. Okay. So this is we call piecewise functions. Just so an idea, you just get idea, that's enough. Huh? Piecewise functions. Piecewise functions. Okay, anyway, you just identify there are many different types. As according to the relation, then we can classify them. So polynomial, rational, irrational, exponential, logarithmic, trigonometric, modulus, piecewise function and so on. There can be many other functions. There can be many other functions. So here generally you need to analyze these type of things under our A-levels. Okay, just write them. Just write them. About this is about classification. Just get an idea. That's enough. No need to worry because we discuss everything again and again. Here y equal x, y equal 1, it is polynomial type, okay? Because 1 mean x to the power 0. Then n I said x to the power n positive integer is 0. Then 1 mean x to the power 0. Then y equal 1, it contain, that belongs to polynomial type, okay? Polynomial type. take further 1 minute and complete. Okay, so I'm telling here general idea, okay, but the thing is in mathematics we have rigorous idea, okay, we have discussed that one very deeply. Now here I told you here variable, x mean a variable, no? Then one is a constant. Then I'm discussing constant and variables. No, constant mean that has specific value that can't change, no? So constant has specific value, but variable can have several values, no? X can get several values, no? Then we call that is variable. So further I said the things about independent variable and dependent variable. So independent variable, it has some values, so that associated with a set, so that x value we can take from that set, no? Then correspond to that we have another value, then that one we call dependent variable, no? Okay, now 1 star mark write down, 1 star mark write down. Constant is a symbol, constant is a symbol or an idea, constant is a symbol or an idea which retains same value, which retains same value through a set of operations, the set of operations. Usually it is a particular number. Usually it is a particular number. Okay, next star mark. A variable is a symbol. A variable is a symbol. A variable is a symbol or a concept which take several numbers, number of values. Those values can be arbitrary. Eligible to take. Arbitrary, eligible to take. Okay, next star mark. Independent variable is a variable which can take arbitrary value from a given set. Next star mark. The dependent variable, next star mark. The dependent variable is a variable that varies with another variable. Okay. Now further you see. So here onwards, y equal fx, you identify functional notation. So here generally x-axis, y-axis. So I told you we can sketch it, no? Here we can sketch it. So we can put value here, then correspond that we can obtain corresponding value. So let's say FA, we denote by FA. Then we call FA mean image of A, and here we call pre-image of FA. Okay, this is graph, no? We can sketch graph by putting some values, no? Y equal x plus 1, it is a line. Likewise, we have several relations. So anyway, this is called pre-image of FA, and this is called image of A. And here, this one we say function. So generally, if you consider a variable, so A mean a fixed value, no? A mean a fixed value, corresponding value again fixed. Here x mean variable, here corresponding here, this is another variable y. So here we say fx. So this one we say fx. So this point we say fx, x variable, y variable, x independent variable, y dependent variable. So A constant value corresponding FA, here that is we call FA image. So now you identify, you consider y equal x plus 1. So let's say fx equal x plus 1, no issue, ne? No issue, fx plus 1. Take this idea first. So you take x values, you find fx values. Fx value mean otherwise we say y, no? Fx mean y again. So when you put 1 here, 1, here f1. The idea of f1 means you have to put 1 here, 1 plus 1. The result is 2. When you put 2 here, you know this thing, f2, but this notation new to you. Here you have to replace x by 2, then 2 plus 1, that is 3, no? Here when you put minus 1, then f minus 1, we say we have to put minus 1, no? Minus 1 plus 1, 0. Okay? Don't do anything other than this. F minus 1, you put right as it is. You don't take minus outside, so on. You can't do anything. Okay? This is not about multiplication. This is an idea. This is notation. Then f1. Then 0, we say f0 mean 0 plus 1 equal 1, no? Then if you need f, if you put some relation like 1 over x, then you say this one f, we have to replace x by 1 over x. So replace x by 1 over x. Likewise, if something here, you have to replace in that relation x value, no? So if we have put 1, then we can get corresponding value. Here these are images, and here these are pre-images, no? Here images and these are pre-images, no? then remember each and every element has unique relation, unique image, no? Okay, put that one as well. Yes, say y is a function of x. Y is a function of x. For now, you forget this one, I'll tell it later. Otherwise, we will mislead. Just right. Okay, now further we go. Now you write definition of function. Write definition. Definition of a function. Definition of a function. Okay, now it's see. So I told you function means interconnection between two variables usually, no? Interconnection between two variables that has specific task. Okay, you think. So I'm the person with some rule. පොලිසියෙන් කියලා තියනවා කියලා හිතන්න මට රූල් එකක් දාලා තියනවා කියලා. මේ පැත්තෙන් එකක් මොකක් හරි දුන්නා ඩබල් කරලා මේ පැත්තට දෙන්න කියලා. Okay, 1 result 2, 2 result 4, 3 result 6. That rule we call function. Then term I use rule. Then that has specific task, no? Specific task. Here there's pool, input pool, and we have output pool, no? Then each and every input must have relation with output. Must have output value, no? That's the thing. Okay, now you write down. Write definition. Let capital X and Y are two non-empty sets. Capital X and Y are two non-empty sets. Two non-empty sets. Then a rule F. Then a rule F. Right? Huh? You write what I am saying. The rule F, which associate each and every element of X. Which associate each and every element of X. Each and every element of X. Capital X, huh? Capital X. With a unique element of capital Y. With a unique element of capital Y. Comma is called a mapping of function from capital X into Y. From capital X into capital Y. Here we write F colon X arrow Y. F colon X arrow Y. F colon X arrow Y. දැන් ඔක මුලින්ම කිව්වොත් ඔයාලට ඔක තේරෙන්නේ නැහැ. හරි. But the function you get idea. That is very simple idea. But we have many properties. Okay. We have critical properties. But anyway you identify it is a mapping. It is a rule. Okay, now here you consider here set X. This is non-empty set. Here it has elements, no? It has elements. So here set Y. It has elements. So each element connect with unique relation. So we call that is a function. Okay, here capital X, capital Y, then capital X into Y. f colon function or rule x into y. Here this way, x into y. We define that is f. Okay, just sketch this one again. Just sketch. So no extra value here. All values has connection. No? Sketch that one. You identify this is a set. Okay, this is a set. This is another set. They are non-empty sets. They have elements. Here x inputs, y outputs. Outputs, no? Okay, now here every element, so I gave definition, no? So there I gave every, each and every I told, no, underline it, each and every, underline that one in that definition, each and every element in X, underline it, and has unique relation or unique, unique, okay, just underline that one as well. So it has unique relation, each and every element, okay, that is very important. Okay, now here this is a set, this is a set, this is another set. So in between them we have connection, no? So here we have elements here, no? Then represent every element. You say here capital X, use variable. Represent every element, use variable. So here one element, then we can use variable, no? So that variable has connection with another variable y here. Here independent variable, here dependent variable, here capital Y. So here this rule we call function f. Then we said again, every element, or we represent here R cross this one, that represent all. Here this notation represent all. All x value has connected with y. All x values. Then here we denote this is fx. We denote this is fx. Then y equal fx. Y equal fx. We put f here. So here x element of capital X, y element of capital Y. These are set notations, no? So here x we call independent variable. So y we call dependent variable. That represent each and every element in capital X. Here y represent each and every element in capital Y, no? So X we call, this is specially now we call domain. Further we denote df. And Y we call range. Specially we call RF, range. Okay, then no extra value here without connection with y. Then every element must be there. Okay, you put that figure as well. Okay. Now you identify capital X mean a set, capital Y mean a set. Capital X we call domain, then all possible inputs, no? Then capital Y we call range, all outputs, no? Then to represent every element in capital X, we use variable X, we call independent variable. So that has connected here Y we call dependent variable, no? Dependent variable. Further, here this is pre-image of Y and Y is the image of X, no? Y is the image of X. Okay, that is general idea. So now you identify, we have another thing, we have relations and we have functions. Not all relations are functions, but all functions are relations. Okay, we have functions and relations, two different things, but all functions are relations, but all relations are not functions. We have to identify that one very clearly. Put that special star mark. Put special star mark and write. Put special star mark and write. Simply a relation is a set of ordered pairs. But function is a special type of relation. That is each and every input has unique output. Within bracket, one and only one output. Okay, now let's see what is that clearly. The major thing, now you clearly resolve this one, okay? Major thing, relation means connection between two variables, but function again, it is also a relation. Clear this one first, huh? So a specialty of function, input has unique output. So let's see this one graphically. Before that you write again. Functions can be identified. Further you write on. Functions can be identified by vertical line test. Within bracket graphically. Okay. Now clear this one. I'll explain one by one. You clear this one properly. So we have one input. Correspond to that we have only one output. So that is function. One input has only one output. Unique output. Then only we say that is function. But there are some relations. One input has several outputs. There are relations, but not that is a function. So function means one input has unique relation. See, you see this graph. Here x-axis, y-axis. See this one. here one input has only one output, no? One input has only one output. One input has only one output. See, one input has only one output, no? Okay, that is a function. A function. See another one. Here you take this graph xy. So let this cut 1, then y equal x plus 1. Take this one x plus 1, here minus 1. Y equal x plus 1 is a function. Now you take this. Take this. Here one x value has one output. One x value has one output. One x value has one output. No? One x value has one output. See? One x value has one output. But if you think reverse order, here one output can get two inputs. No? But anyway, you identify, you have to go input to output. Then one input has only one output. Then this is a function. Then y equal x square is a function. Y equal x square. It's a function. Now you go to this. X equal y squared. See this one. So y equal x square graph is this. Then x equal y square graph is this. That is our graph. Now you see, one input has two outputs, no? Two outputs. So for function, one input has only one output. Then we can't say this is a function, no? This is not a function. This is not a function. Then x equal y squared, x equal y square is not a function. Clear? Clear? Is that clear? Okay. So remember, one input has one output. But here we see this is a relation, no? This is a relation. X equal y square is a relation, but that is not a function. Here y equal x plus 1 is a relation, and again that is a function, no? Then y equal x square is a relation, and that is a function. Identify, one input has only one output. That's the thing. So the vertical line test means imaginary vertical line you sketch. Imaginary you sketch vertical lines. So imagine there are vertical lines. You can see only one intercept there. You can see only one intercept there. Here when you sketch vertical lines, imaginary, you can see only one intercept. Then we say that is a function. You see sketch vertical lines here. Then you can see only one intercept, no? That is a function. Now you go to here, when you sketch vertical line, here we see two intercepts. That is not a function. That is not a function. You sketch vertical line, imaginary vertical line. If we have only one intercept, we say that is a function. That's it. So if you have two or more intercept, we say that is not a function, but that is a relation. No? That is a relation. But anyway, remember, all functions are relations. All functions are relations, but all relations are not functions. No? All relations are not functions. That is the specialty. Okay, anyway, you sketch them. You sketch them. Okay. So if you see graph, now you can identify whether it is function or not, no? Whether it is function or not, that's the thing. Okay, now with star mark write down, now with the star mark write down. Now with star mark write down. Every functions are relations. Every functions are relations. Every functions are relations. But every relations are not function. Every relations are not functions. A given relation can be test. A given relation can be tested. A given relation can be tested by vertical line test. By vertical line test, whether it is a function or not. Whether it is a function or not. Okay, under that write down, sketch vertical lines, vertical lines if at least one vertical line, cut two positions or more positions, that is not a function of x. That is not a function of x. That is not a function of x. Further, if all vertical lines cut at one point with the graph, it is a function. It is a function. It is a function. Okay. Okay, now that is very simple. That is very simple test. Algebraically also we can test that one. Okay. Now you see. You do with me. X-axis, y-axis. You sketch many vertical lines close to each other. Then we see only one intercept, a function. Here y equal x. Y equal x is a function. Y equal x. The next, y equal x squared. You do with me. You sketch many vertical lines close to each other. Now this is very clear, but you just write all. Then is a function. Y equal, yeah, this is we call x cube. Y equal x cube. You sketch many vertical lines, then every of them cut at one point. is a function. Further you go. Here this is we call y equal 1 over x. You sketch many vertical lines. Then we have only one intercept. Is a function. It's a function, no? Sketch them. Sketch one by one. Just sketch. Okay, you see here, there's one specialty. Carefully see that. Huh? So carefully see here, every vertical line is cut at one point. No, every vertical line is cut. So left hand all cases, every vertical line is cut. No, but when you carefully see this one, here this vertical line that don't cut. No, that doesn't cut. So that means here this line especially we call asymptote. That line especially we call asymptote. So it touch, no? It touch, not cut. So all the other lines cut, no? All the other lines cut, but here this one, it touch. So that happened, denominator 0, no? Because of denominator 0. That happened because of denominator 0. So that line especially we call asymptote. Then x equals 0, line is not cut. Cut the graph. It touch. Then it is an asymptote. Asymptote. We call that is asymptote. Just identify. Yeah? Later we will discuss. But anyway, you identify. Here no issue. It is a function. All the other cut at one point, and here no two cut, no, but it touch. No issue. Touching no issue. Cut must be 1. Okay. Okay, here with star mark write down asymptote, denominator zeros. Denominator zeros are asymptote. denominator zeros are asymptote. You just identify, that's enough. Huh? So later we will discuss how asymptote happen and how do we analyze them. With your knowledge, you can't analyze for now because we have to think something like limits and all. Later we will discuss it. But anyway, you identify. Later we identify that. Huh? But for now, you just identify how we identify function, whether it is function or not. That's the thing. Okay. Now I think you can clear that idea. Every relations are not functions, but all functions are relations. All functions are relation. Then function is a subset of relation. Is a subset of relation, no? Can function එක තියෙන්නේ relation එක ඇතුලේ. Okay? Okay. Now let's move one step further. Now we have one algebraical way to find it. So I gave you y equal fx now. We call y is a function of x. Y is given in terms of x. So otherwise we say y has subjected, no? Y has subjected. Y has subjected, no? Y already subjected. Then y given in terms of x. So y to the power 1 subjected means y to the power 1. So now you remember y to the power 1 relations are functions. All the others are right side. Left side we have one value. Then y have expressed in terms of x. Then that is a function. Then algebraically we can see that logic. See, y equal x plus 1, y equal x squared plus 2x minus 1, y equal x over x minus 1, y equal 3x over x squared plus 1, y equal sin x, y equal cos x, y equal e to the power x plus 3x plus 2, y equal log 10 base x plus 1, y equal x plus 1 root. See, all y are given in terms of x now. Y already subjected. So y already subjected means one x value has only one y value. Then all these are functions, no? But we say polynomial, rational, trigonometric, exponential, logarithm, and irrational, and so on. No? But anyway, all together, that is one group. That is function group. Okay? Okay. You write this one. You write this one. That is algebraic way. So that idea very clear. Y is subjected or y has expressed in terms of x or y is given in terms of x. Y is a function of x. No? So every coins represent one thing, that is y to the power 1. That means output has only one. So one input has only one output, no? That's the thing. Here you write all our functions. All our functions. Here when you consider this is relations, so here functions, no? So function inside relations. Better to put that sketch as well. Okay. Now this idea is very clear. So y to the power 1, if we can easily subject y, or if in that relation y has already subjected, then it is surely function. Or one another point, if we can easily subject y, then that is a function again. If we can easily subject y. So you see, easily subjecting y, what is that? So say xy equal 1, you see, xy equal 1. Here y is not subjected, no? But we can easily subject, no? Y equal 1 over x. It is a function, no issue. No issue. You see, 2xy plus 1 equal x. See, you put this on the other side, x minus 2xy equal 1, take y, you put one other side, 2xy equal x minus 1, you divide by 2x, y equal x minus 1 divided by 2x, no issue, ne? We can easily subject. Then it is a function. But you think x equal y squared. So y equal x equal y squared. Now you can subject this, you can subject y, but the thing is, when you subject, you get plus or minus root x, no? Then here y has two possibilities. Then remember that is not a function. Therefore, it is not a function. It is not a function. But here these two are functions. Because they are functions. If y expressed in terms of x, surely that is a function. Y already subjected, no? If y easily subjectable, if it is easily subjectable, then we say that is a function again. But y to the power 2, y to the power 3, y to the power 4 relations, then those are not easily subjectable, no? Then they are not function. Identify. Then only y to the power 1 and 1 over y to the power 1 or y to the power minus 1 easily subjectable. Then they are functions. Others are not functions, no? Okay, anyway, write these examples again. Continue. Okay, now with star mark you write down if y is already subjected, in a given relation, if y is already subjected in a given relation, then it is a function. But there are some relations where y is not given in terms of x at once. Y is not given in terms of x at once. But if y is easily subjectable, then it is a function. Within bracket write down, check the index of y, within bracket write down, check the index of y if the index is 1 or minus 1, generally it is a function. Others are not a function. Others are not functions. Okay, now it is very clear. So, if y is given in terms of x, surely it is a function. If not given in terms of x, but if it is easily subjectable, then that is a function. Now you see, y equal 2x minus 1 over x plus 1. No issue ne? Function. 2xy equal 1 over x plus 1. Function, no? Y to the power 1. 1 over y, 3x plus 1 over x. No issue. Function. We can subject, no? Y to the power 1, y to the power minus 1, but we can cross multiply and subject it. X, y, 3xy plus 2 equals 0. It is function, no? We can subject y easily to function. Then x square plus y square equal 1. Check now. Here we have y square, no? That is a problem. Not a function, no? Not a function, that's it. Then x plus y equal 1 over y. Now carefully see. We have y to the power 1, but that is not subjected. Further we have 1 over y, y to the power minus 1. But if you try to subject y, it is too difficult. Because we have to cross multiply. After cross multiplying, we get y square term, no? Then if I get y square term, that is not a function. No? Then you say this is not a function. So if it is easily subjectable, then only that is function. No? Then y equal 1 over x minus 2 plus 1 over x plus y divided by 3. Here y to the power 1, here y to the power 1. When you put this one, that is easily subjectable, no issue. Ne? It is function. It is function. You can subject y easily. But the thing is here, it is too difficult. Too difficult. No? So anyway, you identify that. Okay, write those examples. Here, correct mark represent it is a function, and here it is not a function. You better write in words. Huh? You better write in words. Okay. Now it is very clear. Now it is very clear. Now we can identify what is relation, what is function. No? We know what is independent variable, what is dependent variable. But we have to think about domain, range, and all. And further, we have to classify. Now generally we can identify everything, but especially we have to think about some properties of each of functions. No? Especially we have to think that. Especially we have to analyze it. Then one by one we need to discuss. Now further I'll go forward further. So especially you identify domain. Domain means all possible inputs. All possible inputs. Then it is a set. Ne? It is a set. So usually that set can be real set or subset of real set. Then output, again a set, no? Again a set, but that output has subjected with x, no? Inputs. That is connected with x. But here x, no interconnection, that has pool, then we can input one by one. Okay. Primitively, then simply function has one specific task. Then there are some machines that can do one task. Then some smart machines, they can do multitask. It can do multitask, no? So we can feed the inputs, then that machine can identify which inputs correspond to which function. Then it do process and give output. Then there are multitasking machines. Then likewise, functions also has multivariable functions. But usually we think about single variable functions usually, and there are some advanced functions as well. There are some functions it's too difficult to analyze. As an example, you consider weight of students with age. Weight of student with age. Age එකත් එක්ක weight එක vary වෙන හැටි. High complex, but we can identify it is variable. It has variation. හැබැයි එක්කෙනාට that variation different. But it is a function. හරිද? දැන් අපි මෙහෙ ඇවිල්ලා අලගෙඩියක් තම්බන්න ඕන කියලා හිතන්න. පුළුවන් නැවුලක් නැහැ නේ. හැබැයි ඒ අලගෙඩියම ගෙනහිල්ලා නුවර එළිය තම්බන්න ගියොත් ওই වැඩේ කරන්න පුළුවන්ද? බෑ. හරිද? Because boiling point varies with height. Boiling point එක වෙනස් වෙනවා. මෙහෙ වතුර අර නටන්න ගන්නවා කියන්නේ. හරිද? සෙල්සියස් 100 කියලානේ කියන්නේ. හැබැයි ඔක 100 නෙවෙයි. 100 වෙනස් වෙනවා. normally 100ෙන් තමයි normally කියන්නේ theoretically it is 100 celsius. ඒතර මේ හරියදී අපි සාමාන්‍ය මේ level එකේදී sea level එකට ලං වෙනකොට වගේ අපි ඔක 100ට ළඟ තියෙන. සමහරවිට 100ට උඩ යන්නත් පුළුවන්. හරිද? 100ට උඩ යන්න පුළුවන්. හැබැයි උඩට යන්න ඊට කලින් ඒක නටනවා. ඒතර දැන් හිතන්නකෝ මෙහෙම temperature එක 50 celsius 70 celsius 80 celsius 100 celsius 110 celsius හිතන්නකෝ මේ මෙන්න මෙතන තමයි අල තැම්බෙන්න ගන්න කියලා හිතන්නකෝ 98 celsius 98 celsius එහෙනම් අපේ boiling point එක around 100 නම් no issue මේක අර නටන්න කලින් තැම්බිලා තමයි වෙන්නේ no issue possible හැබැයි අපේ boiling point එක මේ හරිය තියෙනවා නම් දැන් තැම්බෙන්න කලින් නටනවා හරිද එහෙනම් ඒක සෙට් නෑනේ එහෙනම් ඒකත් variable but they are too complex scenarios no too complex to analyze but it is a function then natural things we can discuss with functions then every natural relations we can discuss these functions but we need smart function no we need smart function to discuss that one that's the thing but anyway we gonna create some functions to analyze nature we gonna create functions to create new things that is the specialty okay AI works with functions multi-million functions that can learn, that can give output. That can learn, that can give output. Then that function has ability to learn. Then as a human we can learn. No? එන අපි ගාවත් ෆන්ක්ෂන් එකක් තියෙනවා learn කරන්න පුළුවන් ෆන්ක්ෂන් එකක්. ඒතර ඉස්සර machines වලට learn කරන්න පුළුවන් වුණේ නැහැ, වැඩක් කරන්න පුළුවන් වුණා. හැබැයි දැන් තියෙනවා functions machine එකට learn කරන්න පුළුවන් functions. Okay? අනේ වගේ logics තියෙනවා. එහෙනම් මේ function කියන්නේ මාර රෝල් එකක් ඇක් කරන අපේ mathematics වල. මාර රෝල් එකක් ඇක් කරනවා. ඔයාලා computer programs ලියනවා කියලා හිතන්නකෝ. computer programs වලින් කරන specific task නේ. specific task කරනවා. ඒතකොට task එක handle කරනවා function එකේ. අපි side එකෙන් function එකක් ලියනවා. අපිට වැඩේ වුණාම function එක call කරලා වැඩ කරලා එළියට දානවා. Side by side we gather functions, then we call it and we process and give output. No? Likewise, many applications we use functions. Then mara important thing එකක් මේක. Okay. Now let's move a little further. So I was telling the things about domain and range. So here set x. Here corresponding set y. Here all xl has connection with y. So we say that is fx. Here we denote by f. So here x, simple x element of capital X, simple y element of capital Y. No, this is general idea. No, then here this all possible input set, all possible input set is the domain. Is the domain. Capital Y, all output set corresponds to input. So that corresponds to input is the range. That's the range. Okay. Usually input subset of real set. Usually real set. Usually a subset. A real set. So if it is real set, we say real function. Real functions. If we use any subset of real set, we say that is real function. That's it. Okay, put that one. Put that one. You better write here real valued functions. Real valued function. Okay, now it is simple. Now it is very simple. So all possible inputs belongs to domain. No? So function, කාට හරි function එකක් ඕනේ කියලා හිතන්න. You assume that anyone need a function. Then he must give domain. He must give domain. If somebody use function, he must give domain. Okay. If that is not given, you must have ability to obtain what is domain. Okay, we clear that idea. Okay. If anybody give function, he must give domain. If it is not given, you must have ability to find domain. So you must have ability to find domain with some conditions. So there are special conditions. No denominator 0 is possible. Within square root always positive or 0. Within logarithms positive. We have 3 special conditions. You must know that condition. So if function is given, so if you need to find domain, what is domain? That your selected domain we call implied domain. Is it okay? So identify. If function is given, so that man need to give is domain. හරිද? එයා domain එක දෙන්න දැනගන්න ඕනේ. If it is not given, you must have ability to find domain. You must have ability to find domain with special conditions. So especially we have 3 conditions. One condition, no denominator 0 is possible. Another condition, within square root none negative. Within square root none negative, that means within square root 0 or positive values are possible. Third condition, within logarithms always positive. Always positive. We have only 3 conditions, that's it. Okay, just write. When the function is given, when the function is given, corresponding domain must be given. Corresponding domain must be given. Corresponding domain must be given. Within bracket write down original domain. Within bracket write down original domain. ඒක මගේ word එකක් හා. ඒ කියන්නේ ඔයාලට අඳුර ගන්න කියන word එකක් ඒක original domain. If the domain is not given, continue now. If the domain is not given, if the domain is not given, suitable domain must be selected. suitable domain must be selected. Suitable domain must be selected, which is called implied domain. Which is called implied domain. Implied domain. Which is called implied domain. We select further right. We select implied domain. We select implied domain with three special conditions. With three special conditions. With three special conditions. One, no denominator zeros are possible. No denominator zeros are possible. Two, first one, no denominator zeros are possible. Two, within square root, no negative values are possible. Within square root, no negative values are possible. Third, within logarithms, always positive values are possible. Okay, you get that idea. Later we practice it. Later we practice it how to obtain domain. Okay, then same way we can identify range. Okay, so usually that given person must give corresponding domain, otherwise we have to select it. Okay, that's one we call implied domain. Okay, now one another step further. Now you say f, here x set, here y set, colon, here we say x into y map, capital X into y mapping, f into y mapping. We have a map. Path එකක් තියෙනවා, we have map. Okay, x into y mapping. So that has connected with relation, no? That is connected with relation. So further you see, here consider x set, here consider y set. So let's say we have several inputs. So here they have connections, but see here these two not connected with the other one. So this is not a function, no? This is not a function. Definitely every element in this set must have connection with the other. So here two extra element is not a function. Here this is the problem. Further, here x set, here y set. Here we have several inputs. So we have connected y values here. Here this is our mapping. So here unique value, no issue. You say, here there are some extra values here, output pool. So input pool, no extra values, but output pool we have extra values. You think practically. So we have machine, we have input. If I give input, that give output, no? So consider output basket. Consider that basket. So in that basket, there can be some extra values, no issue. That not affect with machine, that is not affected with machine. Then surely and specially all x values must be connected with y, no? But output pool, there can be some extra values. Then no issue here, is a function. It's a function. But anyway, here this set we call, here this we call range, and here this called codomain. So if we have some another extra values there, then it is a set, no? But exactly corresponding values we say that is range. Then there can be some extra values in output pool, then that is we say codomain. Here this one domain. Then if we have some extra values in domain, then that is a problem. Then you don't say that is a function, but there can be some extra values in that pool, output pool, okay? Then no issue, that is a function, no issue, no effect. Now further you see, so here we have connections, we have mapping. Okay, now you see here each and every element has connected with this one, no? And no extra values here and no extra values there. That is very special. So no extra values in output pool. Then this is we say especially onto relation, onto relation, onto relation. Or onto function. Let's just say onto relation or onto function, but it is okay. Onto. Then here the specialty range, codomain, both are same, no? Both are same. Then no extra values in there, no? That is we call onto. See another one. See another one. Here one element, one connection. See, here there are some extra values. Here x set, y set. So no issue, this is a function, no? This is a function, no issue. So all element in x has connected with that, no? No issue, but here there are some extra values, but that is not a problem. That is not a problem. But here there's one specialty. If you clearly see, one element has one element, output element. One input element has only one output element. One element, one input element has one output. But here, one element, one. Here, two element, one. Here generally, here only thing here, only range codomain equal thing. But here specialty, one element has one output. One has one output. We call that is one-to-one relation or one-to-one function. Here we say one-to-one. One-to-one. Okay, one-to-one. One-to-one relation. Further you see, this. Here one element has one output, one element has one output, one element has one output. And further, we don't have any extra values there. Here one element has one connection, no extra values. But here one element has one connection, but there are some extra values, no? So here this is onto, and this is one-to-one. One-to-one. But here surely this one not onto, ne? This is not onto. Because range and codomain different, then this is not onto, this is onto. And see this one, this is onto as well as in one-to-one, no? Here range and codomain both are same, then this is onto function surely, as well as this is one-to-one function. Both happen there, no? Then one-to-one and onto. One-to-one relation or onto relation, and one-to-one and onto relation, no? Both there. So now this is very special. This is special, this is special, this is very special because both in there. කවුරු හරි කෙනෙක් මෙහෙන් පැන්නොත් he can jump again back, no? Because there's a path here. He can jump back. Here he can jump back, no? Here we can jump back, but the problem is everyone can't jump, no? Everybody can't jump. එතන මෙයාට reverse වෙන්න බෑ. This can't reverse, but here this can reverse. මෙතෙන්ට ආවම here this element has path to reverse. But when you consider these two elements, 2 input 1 output, එහෙනම් මෙයාට දැන් trouble එකක් තියෙනවනේ. මෙතනින් මෙතෙන්ට පයින්නවද මෙතනින් මෙතෙන්ට පයින්නවද කියලා. නේ? There's a trouble. Therefore here this type can't reverse. This type can't reverse. But here surely this can reverse, no? Then inverse function appear from there. Then if it is one-to-one and if it is onto, then inverse will appear. Then inverse process possible. Inverse process. Here one process, then reverse process we call inverse process. So in engineering we have engineering and we have reverse engineering. We have reverse engineering process. So if we develop something, so that developed object we can analyze and we can get back the raw material and all. Okay? So we have inputs, ne? So that will give result. So analyzing that result, we can reverse the process one by one and we can take that up to raw material. Okay, that is reverse process, reverse function, inverse function. Then this is very special, one-to-one and onto. This has inverse. An inverse function. Inverse function. Okay, you just write all, you just write all. Just write all. So that is about types of functions. Huh? Just write types of functions. Types of functions. Okay. 1 star mark, write down. Okay, right. 1 to 1, 1 to 1, write down. 1 to 1 or 1 to 1 or injective. 1 to 1 or injective mapping means 1 to 1 or injective mapping means only one element in the domain. Only one element in the domain has one unique element in the range. Comma, otherwise it is many to one. Okay, so we have 1 to 1 relation, otherwise it is many to one. 2 to 1, 3 to 1, so on. Yeah, 2 to 1, 3 to 1, or otherwise we say many to one. So especially 1 to 1 is the thing. It is we call injective, otherwise many to one. Okay, next star mark. If codomain and range are same, it is onto. It is onto. If codomain and range are same, it is onto functions. Onto or subjective mapping. Another star mark, write down. Another star mark. If a function is 1 to 1 and onto, if a function is 1 to 1 and onto, if a function is 1 to 1 and onto, that function can have an inverse function. That function can have an inverse function. That function can have inverse function. Under that you sketch this. Here set x, here set y. Here one element has one image, 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 so on. Then it is 1 to 1 and onto. Wait a second. So no need to sketch all. Wait a second. Let's sketch only one. So say all x values as connected with y values. We say fx. Here this function 1 to 1 and onto. So we can reverse again. Here we call inverse function. Here all x values now. Further we say f inverse y. Here domain of f. and further domain of f or range of y, no? Domain of f, range of f inverse, no? Here domain is the range of inverse, no? Here domain and range of the function, and here domain of the inverse function and range of the inverse function. That has interchange, no? Variable interchange. Then range of f inverse, and further we say this one, range of f, otherwise we say domain of f inverse, no? Here that means domain range has swapped, no? They have interchange. Variables has interchange again. Independent variable, then dependent variable of function. Then here independent variable of inverse, and here dependent variable of inverse, no? That has interchange. That is special thing. Okay, just sketch this one. Okay, then that's about inverse functions, huh? That's about inverse functions. So now we have discussed many things about functions, but further we have discussed the identification of domain range. We have to practice it, and we need to obtain inverse function by function, and we have discussed odd functions, even functions, and all. We have discussed only few things, but major part completely done. Anyway, next day we can complete this full lesson. So we can practice all the actions next day. Then we can wind up that functions part next day. Okay, that's enough, no?